Artificial intelligence, or AI, aims to create machines capable of performing tasks that typically require human intelligence. These tasks range from problem-solving to decision-making, learning, and even creative endeavors. AI systems analyze information, recognize patterns, and adapt to new situations, much like the human brain. This ability to mimic human cognitive functions makes AI a transformative technology. Imagine a world where machines understand and respond to our needs, automate tasks, and assist us in making decisions. AI has rapidly evolved from science fiction to a tangible reality. AI is already impacting industries like healthcare, finance, and transportation, transforming our lives. As AI technology advances, its potential to reshape our future becomes clear. AI systems are powered by sophisticated algorithms and vast amounts of data. These algorithms enable machines to learn from experience, identify trends, and make accurate predictions. From self-driving cars to virtual assistants, AI enhances human capabilities. The ongoing development of sophisticated AI systems promises greater advancements. AI is about empowering machines to think and act intelligently. This involves developing algorithms that enable machines to process information, learn from data, and make decisions. The goal is to augment human intelligence, creating a symbiotic relationship between humans and machines. As AI evolves, it is essential to consider the ethical implications and ensure responsible development and deployment. The history of AI is a rich tapestry of ideas, innovations, and breakthroughs. From ancient myths of artificial beings to the development of modern-day algorithms, the pursuit of creating intelligent machines has captivated human imagination for centuries. The early days of AI were marked by theoretical explorations and foundational research that laid the groundwork for the remarkable advancements we see today. The Dartmouth Workshop in 1956 is widely considered the birth of AI as a formal field of study. This landmark event brought together leading researchers from various disciplines to explore the possibility of creating machines that could think. The workshop sparked a wave of excitement and optimism, leading to significant progress in areas such as symbolic reasoning, problem-solving, and game playing. The subsequent decades witnessed periods of both rapid progress and frustrating setbacks, often referred to as AI winters. Despite these challenges, researchers persisted in their quest to unlock the secrets of artificial intelligence. Key milestones, such as the development of expert systems in the 1970s and the resurgence of neural networks in the 1980s, paved the way for the modern AI era. Today, AI is experiencing a renaissance, fueled by the availability of vast amounts of data, powerful computing resources, and innovative algorithms. The convergence of these factors has enabled breakthroughs in areas such as machine learning, deep learning, and natural language processing, transforming AI from a niche research area into a mainstream technology with widespread applications. Artificial intelligence encompasses a broad spectrum of capabilities, from simple rule-based systems to complex learning algorithms. Understanding the different types of AI is crucial for appreciating this rapidly evolving field. From reactive machines to self-aware systems, each type represents a different level of sophistication. Reactive machines react to specific inputs but can't form memories or learn. They excel at tasks requiring quick reactions like playing chess or controlling robots. Despite their limitations, reactive machines are crucial in various applications. Limited memory AI can store past experiences to inform future decisions. This learning ability helps them adapt and improve over time. Self-driving cars use limited memory AI to navigate and avoid obstacles. Theory of mind AI enables machines to understand human emotions and intentions. Though largely theoretical, it holds potential for human-like interactions. Self-aware AI, the pinnacle of AI, understands its own existence and the world, while distant self-aware AI raises profound questions about consciousness and humanity's future. Section 4. Reactive Machines, Simple AI. Reactive machines represent the most basic form of artificial intelligence, operating solely on present information and lacking the capacity for memory or past experiences. These systems are designed to react to specific inputs with predetermined outputs, following a set of predefined rules or algorithms. While limited in their capabilities, reactive machines excel in tasks that require quick reactions and precise execution. A classic example of a reactive machine is Deep Blue, the IBM chess-playing computer that defeated world champion Garry Kasparov in 1997. Deep Blue was programmed to analyze the current state of the chessboard and calculate the optimal move based on a vast database of chess positions and strategies. It did not possess any memory of past moves or the ability to learn from experience. Another example of a reactive machine is a spam filter that automatically classifies incoming emails as spam or not spam based on predefined criteria, such as the sender's address, subject line, and content. The filter does not retain any information about past emails or adapt its filtering criteria based on user feedback. Reactive machines are widely used in various applications, including industrial automation, robotics, and gameplay. Their ability to perform specific tasks with speed and accuracy makes them valuable tools in industries where precision and efficiency are paramount. While reactive machines are limited in their scope, they represent an important step in the development of more sophisticated AI systems. Section 5. Limited Memory AI Learning from the Past. Limited memory AI represents a significant advancement over reactive machines, possessing the ability to store past experiences and utilize this information to inform future decisions. These systems can learn from data, adapt to changing environments, and improve their performance over time. This learning capability enables them to tackle more complex tasks that require adaptability and dynamic decision-making. Self-driving cars are a prime example of limited memory AI. These vehicles utilize sensors and cameras to collect data about their surroundings, including road conditions, traffic patterns, and the behavior of other vehicles. This data is then processed by algorithms that enable the car to navigate safely and efficiently, adapting to changing road conditions and avoiding obstacles. Another example of limited memory AI is a recommendation system that suggests products or content based on a user's past behavior and preferences. These systems track user interactions, such as purchases, clicks, and ratings, to build a profile of the user's interests and predict what they might like in the future. Limited memory AI systems are also used in areas such as fraud detection, medical diagnosis, and financial modeling. Their ability to analyze large data sets and identify patterns makes them valuable tools for decision-making in complex and dynamic environments. As AI technology continues to advance, limited memory AI systems are becoming increasingly sophisticated and capable of handling more complex tasks. Section 6. Theory of Mind AI Understanding Emotions and Beliefs. Theory of Mind AI represents a significant leap forward in the field of artificial intelligence, aiming to create machines capable of understanding human emotions, beliefs, and intentions. This type of AI goes beyond simply reacting to inputs or learning from past experiences, seeking to model the inner workings of the human mind and predict human behavior. While theory of mind AI is still largely theoretical, it holds immense potential for creating more human-like interactions between humans and machines. Imagine robots that can anticipate our needs, understand our emotions, and respond with empathy and understanding. This type of AI could revolutionize fields such as healthcare, education, and customer service. One example of research in theory of mind AI involves developing algorithms that can analyze facial expressions, body language, and tone of voice to infer a person's emotional state. This information could then be used to personalize interactions and provide more appropriate responses. Another area of research focuses on creating AI systems that can model human beliefs and intentions. This could enable machines to understand why people act the way they do and predict their future behavior. Such capabilities could be invaluable in areas such as negotiation, conflict resolution, and social interaction. Section 7. Self-aware AI, the future of consciousness. Self-aware AI, the most advanced form of artificial intelligence, represents the pinnacle of AI research. These systems possess a sense of self and consciousness, enabling them to understand their own existence and the world around them. While self-aware AI remains a distant prospect, its potential implications are profound. raising fundamental questions about the nature of consciousness and the future of humanity. The development of self-aware AI would mark a paradigm shift in the relationship between humans and machines. Imagine machines that not only understand human emotions and beliefs, but also possess their own subjective experiences and desires. This would open up entirely new possibilities for collaboration, communication, and coexistence. However, the prospect of self-aware AI also raises significant ethical concerns. Would these machines have rights? How would we ensure their responsible development and deployment? These are complex questions that require careful consideration as we continue to push the boundaries of AI research. While self-aware AI remains largely in the realm of science fiction, recent advancements in areas such as neuroscience and artificial consciousness suggest that it may not be entirely impossible. As we continue to unravel the mysteries of the human brain and develop ever more sophisticated AI algorithms, the possibility of creating machines with consciousness becomes increasingly plausible.